This is some of the concepts that we'll be dealing with as we learn to think logically in geometry. And the first concept, or the way that we'll deal about talking logically, is a postulate. A postulate is also known as an axiom. Those are synonymous. And a postulate or an axiom is something that we will accept without proof. Today we'll have some postulates. Some folks call them, some mathematicians call them postulates, some call them axioms, and both are correct. That is opposed to a theorem. A theorem is something that we will prove. We'll have a lot of theorems, just a few postulates, but a lot of theorems in this class, and most of the theorems we'll either prove or we will at least demonstrate. A pretty much well-used abbreviation for theorem is THM. You're welcome to use that abbreviation if you want to do it. Notice that this is not the word theory, so please don't use the word theory. So the first one we're going to have is the ruler postulate. The ruler postulate is, I can make a ruler. Well, let's see if I can make a ruler. Okay, I'll take a line segment. I'll measure off convenient lengths of approximately the same size. I can name those lengths, and I can also number them. So these numbers that I've placed correspond to the coordinate of where the point is located. So we think of this as a one-dimensional coordinate for where the point is located. Okay, I can make a ruler. I made a ruler. I can use a ruler. How would that work? Okay, say this is point A and this is point B. I can use the ruler to determine what the distance is between point A and point B by subtracting. Here, I would choose a larger number, do 5 minus 2, and get 3, and know that the distance from A to B is 3. So that would mean that the distance from A to B, or the length of that segment going there, is 3. Now, to generalize on this so that it's always useful, notice I just automatically chose the big one minus the small one. If I didn't, I'd have done 2 minus 5, and that would have been negative 3. What's the problem with negative 3? Well, let's look here. There are no negatives on a ruler. There is no such thing as a negative distance. And so we'll want to make sure that whenever we have a distance, it's positive. How we would normally do that in real life is to just do 5 minus 2 rather than doing 2 minus 5. However, in many circumstances, we won't necessarily know which of the locations has the highest coordinate value. So let's think of this, since it's our basic first one, as an x value. We'll call B x sub 2 and A x sub 1. So to generalize, we could say that x sub 2 minus x sub 1 absolute value is the distance between A and B. Remember, we'll write the distance between A and B as AB without a bar on top. If it had a bar on top, that would mean the geometric figure that is the line segment AB. So here's a more nicely written out version of the postulate, the ruler postulate. Okay, so now we'll do segment addition. Let's see how that'll work. I'll start with okay, so here we have a line segment AC, and notice that B is between A and C. That creates two smaller constituent line segments, AB and BC. So we can work with this, and we can say that AB plus the segment AB plus the segment BC together makes the segment AC. And we can also say, let's see, the lengths AB with no line on top plus BC is equal to the length AC. I'll talk more about the difference on that in a minute. But notice for the moment that what we have here is that B is between A and C. So if we know that B is between A and C, then we can conclude from that both of these things. That is, that you add them together, you get it. Or the sum of the whole is the sum of the parts. But notice this also goes back around the other way. If we know that we can add it together to get the whole, then that means that the one in the middle must actually be in the middle, or between. So this is the segment addition postulate. The whole is the sum of the parts. Here's the more formally typed out version of that.